Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream, on Twitch, no engines, no libraries, just us and our typing fingers. Right now we are in the middle of converting our game from using just loading bitmap and wave files off disk to using a asset file, like a pack file of our own creation, and we are about halfway through writing a test version of that. And so today what we're going to do is finish the piece of test code that writes out an asset file that we can then start loading in to the game. So yeah, not a lot to talk about because we've already talked about all of the concept involved, so really we just need to finish coding it. It's day 149, so if you would like to follow along at home, you are going to want to follow along with day 148's source code, unpack that into a directory, and you'll be exactly where I am at right now. So if I go ahead and pull back up the code here, that we were using, test asset builder, we stepped through it yesterday and got it to the point where it was essentially writing out most of the asset file header, except for the asset array itself. And what we wanted to do now was actually write out the asset array, and in addition to the asset array, we also want to basically, include the assets themselves in here too, right? Obviously that, makes some reasonable sense, right? So what we would like to do here is we would like to have something that spins through the assets and writes them out and actually puts in the asset array that also tells where they are. And if you remember the way we did this asset array in the file, this is not what I wanted at all. I want this asset, file formats, right? The way that we decided to do that is we have this HHA asset here, and that HHA asset is going to be written to the file in a way that tells us where the data for the thing is, where the tags for it are, and how many that there are, right? And inside there is either going to be the definition of the bitmap that we need, which would be the dimension and the alignment, or if it's a sound, it's going to tell us, oh, well, you know what? We really don't need first sample index. I don't know what that's doing there. There's just a number of samples and whether this is chained with another, some other sound in the system, right? So that's really all we actually need. It's really pretty straightforward. And so what we need to do now is just actually write this stuff out. We're essentially writing out all the other things. We're just not writing out this. And so what I'd like to do is actually write it out. Now, if you look at the way that we wrote out the other arrays, what we did is we had them in memory exactly as they would be in the file. And remember, files and memory are like the same thing, right? A file is just a permanently stored version of memory. They're just bytes. There's nothing magical going on there, right? There's just a bunch of cruft involved in actually like getting them out to a solid state drive or a hard drive or whatever. But in the end, we're just talking about storing binary data, just like the kind that we've been manipulating in memory. There's no magic to it. So when we do a write like this write, we're just saying take this block of memory, put it to the drive, and later on, in the game, I'm going to want to pull it back in as it is, right? And so the thing is, these were just written out as big fat blocks because we happen to have the arrays exactly as we want them to be. In this case, as I go through the assets, I haven't actually prepared an asset array yet because I haven't gone through all the assets and figured out where they will be stored. Because remember, when we're looking at where each asset will go in the file, it's this big long linear series of bytes. I have to put each asset like after one another. So if I write out the first bitmap, then the second bitmap, the third bitmap's location is going to be dependent on how big the first and second bitmap in the file were, right? And so I don't really know what the data offsets are till after I write the other things. So there's two ways we could choose to handle this, and I think I'm going to handle it in the simpler way. There's two ways we could choose to handle it. One way we could choose to handle it is write all the assets out, but leave space in the file for the asset header, the asset array, and then go back and write the asset array out as a chunk. I don't think I'm going to bother doing that. What I might do is just do the simpler thing of writing out the asset array as individual pieces as we go and write the actual assets in. Because we know where the assets will start, right? We already figured out where the assets will start because it's whatever this location is plus the size of the asset array is the first free available byte in the file, right? So what I'm going to do is I think I'm just going to go ahead and loop manually over the asset set, right? So I'm going to start with asset index 0. I'm going to go through the number of assets that we have, and I'm going to do using a seek. And this is kind of an inefficient way to do this, but again, this is not code that we care at all about. It's never going to run on the end user's machine. This is just, well, first of all, it's test code even for us, but it's our asset file creation stuff, which only happens on our machine, and we don't care at all unless it becomes some kind of a production problem, how slow it is, right? So we don't really have to care about how efficient or inefficient this may be. We don't care at all. So what we need to do here is we basically need to do our own kind of streaming, right? We need to do our own location tracking. Because what we want to do here is we want to jump to the part of the file where this particular asset goes, whichever one it is. We want to write out the data there for the actual asset. So the bitmap, like pixels if it's a bitmap, or the sound samples if it's a sound. And then we want to like jump back, right, to the asset array and put it in there. Or, you know what? Now that I think about it, it's not actually any easier doing it that way. Really, if we just do one fseek to put ourselves past where the asset array is, I think the thing I said first is actually better, right? Because then what we would do is we just fseek, stream out all the assets in order, right? And then jump back to where the asset array is and write it out there. That seems actually totally fine. So there we go. All right, I changed my mind in the middle of describing even what I was going to do. So there you go. All right. So what we want to do here is we've done an fwrite, and we could almost even, you could see what we're essentially doing is instead of writing out the asset array here, we just, because like I said, we can't give it the position to write at. It's going to write wherever, at the end of wherever the last write was. That's just how the C API works, even though that has nothing to do with how hard drives work at all. That is how they chose to implement it, probably because they were thinking of tape drives or terminal streaming or something like this back in 1970 or whatever. But point being, that is not what we want at all. So what we wanted to be able to do is say, let's just skip the place where the asset array is. We could just write out what garbage there and then come back and write it later, but we might as well not tell the operating system to do work it doesn't have to do. So what we want to do is be able to do this thing fseek, right? And what fseek does is fseek allows you to move the file position that C is thinking about in its standard library to a different location without actually writing anything. And you can see it allows you to specify sort of the way in which you want it to move. And you can see its definition here, right? So you pass that file handle that we're talking about, so it knows which stream it's talking about. You pass a value that's sort of the amount you want to move. But that amount doesn't actually mean anything until you look at the third parameter, which says how you want that to be interpreted. And there's three ways you can do it. You can say seek set, and if you say seek set, it will seek to that absolute byte in the file. So if you say 5, you're talking about the 5th byte in the file total. You can say seek cur, which is like saying, oh, let's go ahead and say wherever I am right now, add this many bytes to it, or subtract in the case of a negative number, right? And then finally, seek n says start at the end of the file, wherever the last byte was written to the file in its history. I want to start there and move from there. So if I want to like back up a bit from the end of the file, I can do that, right? And so what I'm going to do is I'm going to basically just say, I know the asset array size is this big, right? I know that's how big the asset array size is. So I'm just going to say from the current position, right, I would like you to skip however many that was, and get to the next location, and then the location of the file that would start immediately after that, right? Then I'm going to spin through the asset arrays. I'm going to write out each individual asset, right? And then when I get to the end, I want to seek back to this location, right? So now I want to be able to say, you know what? Go seek back to asset array location. And it just so happens that I already know that as well, because we stored that in the header, right? The place where the asset array was, we already sort of saved because we had computed where we wanted everything to be laid out, right? So that's all good. So this is going to be pretty straightforward. There's not a whole lot to it. It's all good. There's only one caveat. And the compiler will complain about it, presumably, actually, for us. And that is that we are using 64-bit file offsets. And unfortunately, the C API doesn't actually support 64-bit file offsets. So in this case, we don't care, because in this case, we happen to know that this is not going to be outside the 4 GB range. It's at the beginning of the file. So in this case, we can just do that if we want to, right? But if you wanted to be able to handle seeking around very large files, you have to kind of go off book a little bit. And there are various things like lseek and sort of these other things that take larger offsets for 64-bit files. I'm going to leave that as an exercise to the reader because, like I said, this is only test code, and when we are actually doing our reads from this file, we will not be using the C runtime library. We'll be going straight through Windows and doing I/O completion port overlapped I/O, which has no bearing whatsoever on any of this stuff. So in this case, this is totally fine, but just so you know, there are actually sort of newer, more recently introduced things that are, I don't even know if they ever actually became C standards, but they are kind of de facto standards. Like there are ways that you can use the C runtime library to handle 64-bit offsets if you really cared to do so. We will not be doing that on Handmade Hero. So, all right, now we've got this asset array, right? We've kind of got a problem here, which is that this asset array that we're writing out, the asset array is a different array than this one, because this asset set we made here is actually just a record of like the files we wanted to read from, right? But it's not actually the asset array that we really, in fact, actually wanted. And so what I might do, just to make it a little bit more straightforward, is I think I'm going to go ahead and bifurcate this and say that we have the HHA asset set, right? And these are the assets that are in the file. And this is like the, so we have like asset sources and asset data or something like that, right? And so our actual asset that we store in here is just probably, we don't, all of this stuff will actually be, well, I guess it's these, right? The only things that we might have, right, is this, right? We'd have something like this. These are the pieces of information that we might need in addition to what we had. And you know what? The other thing we might need is asset type, and it would be like, oh, is a sound. I guess we could even just do, well, I'll do it this way. Asset type sound and asset type bitmap, because since the game already knows what they are, but we don't actually know in this asset processor except when we actually announce them, we might need something like this. So that's all the additional data that we need, right? That's only used for processing and is not saved in the file. So that way we can just fill out our asset sources, right? We could say asset source, something like that. We can just fill out our asset sources and our asset data together. We write out the asset data, and we never bother writing out the asset sources, because that's just markup, right? And so that's what we're talking about, right? So we would say here asset data, right? And we would write that out. And then in here, we would go ahead and grab these things. HHA asset. Let's see, HHA. Right, oh, this would be like source and dest, maybe, even, you could say. So we've got these guys, and I'm just going to grab out the pointers from the actual asset set, just so we can talk about them a little bit more easily in this code, right? All right, so here we go. We've got these guys ready, and what I'm going to do now before I actually implement this is I'm going to fix the compile errors that will be generated from this change that I made where I say that I want these two things to be split. And so what I'm going to do is I'm going to, I think I want to kind of make this a little bit less pointer oriented, if you will. So I want to kind of see how these guys are getting used. I want to say that this debug asset, also I guess we don't really need to do that, but this is going to be essentially a asset index now, right? Something like this. And I'm going to go ahead and clean up these compile errors so that that all works. All right, so what we want to do here is say that our, what did we actually call these? Our asset data. Maybe I'll leave that as assets so it can still be used in most places. So what I want to do here is I want to change these routines to work in sort of the split format. So I've got, my asset source, and I've got my HHA asset, and those two things are different, right? And these things here, I guess all can stay roughly the same. That's all similar. I don't think there's anything odd there. Oops, and I've got to have a differentiating name for these guys. So I'm going to call these source and dest for the moment as well, because I don't know, that's the way I'm thinking of them. All right, so, well, maybe we'll do it this way. Maybe I'll do it that way. I think that's a little bit clearer. All right, so in the HHA, we've got it looking like this, right? I think all of that stuff is correct. And when we do the sounds would be similar, right? We come through here, and we've got the HHA version set up this way. And we're going to go ahead and pull out the parts now that are in only the source. So there's the source for bitmap is just the file name. That's all there actually is. And then we've got the type, right? I said we were going to have the type is asset type bitmap. And then down here we've got that file name and first sample index, right? Those are both part of just the source, like so. And then again, we want to set that type to asset type sound. Okay, and this is HHA as well. This should be debug asset. So this right here is just assets asset index equals result dot value, right? And we're going to track that. So in both cases. So, and clean these guys up. Left of value, sound next ID to play is just that now. All right, so we want to assert that the asset index, right, is not equal to 0. So we do actually still want to do this assertion because that's the null asset. So we want to still check that. And then here, what we would need to do is the asset itself would have to be sort of grabbed out of that. In order to do the increment here, we have to actually have the asset source. So this would be HHA asset, asset, I guess we'll call it HHA to be a little more consistent. HHA equals assets, asset sources, plus asset index. Yeah, and that, oops, not asset sources, just assets. Yeah, and so that's all good, and just gotta clean up a couple other things here. Nothing particularly unusual going on. All pretty basic. This is actually dot value, and there we go, asset source. And I think that's it. So yeah, that is pretty much it, I think. And that will, in theory, write out everything correctly if in here we actually did asset processing, which we're not doing yet, but that's what we're about to do. So I'm going to go ahead and run that and see, make sure there's no particularly odd things going on there. And then I'm also going to dir our handmade data directory to kind of see what is happening there. There is our test.hha. I don't know if that's the right size or not. I would have to think about whether it is or not. We don't have that many things in it, so it seems semi-plausible. We'll have to check to see if that all makes sense. So anyway, let's go ahead and finish implementing this stuff. And so inside our handmade asset, now is the time when we would be moving out like that bitmap code, right? So we have handmade asset .cpp, and you can see we've got like the bitmap header and the wave header and all this stuff, right? So I'm not going to delete it from the game yet, but it's going to get deleted from the game, right? Like that's eventually going to go away. So for now, what we're going to do is we're going to just, is top down aligned? Where is that actually? It's not even used anymore, right? We could just delete that, can't we? Yeah. So what I'm going to do is just copy in this code that we had, that we were using, And then once I am confident that everything is all set up properly, I am going to delete it from the Handmade asset, because we're not going to load things from BMP files anymore after that. Okay, so here's that code. And you know what? This could even go down in here now. There we are. So yeah, I'm going to compile that and see what we're missing in terms of whatever we might be missing. So we've got our align percentage, and is that just simply getting stored in here? It never actually gets used, so that's not necessary, and I'm just going to go ahead and get rid of that anyway. Let's see, and loaded bitmap, like this stuff. I guess we could still use loaded bitmap. I think that's in the renderer, right? Loaded bitmap. So I can put that in here. Now we don't actually want the align percentage. Width over height we do need, but we can reverse calculate that when we load it in. That should be fine. So we're actually totally fine with just this, I think, in terms of what's getting loaded, right? So we need debug platform read entire file. We need to implement that. We don't have that yet. And we need that to return some kind of a thing that reads. We'll just put one of those in here. We'll assume that we have that, and that'll be fine. And that it returns exactly the same stuff, a contents and a content size and a contents, right? So we'll basically have a read file result. Or I guess we could just call it entire file, right? An entire file would have a size, and it would have a contents for now, right? So yeah, we'd call read entire file. Read entire file would return an entire file, and it would just take whatever the file name is that's going to be loaded, and it would return one of these guys, right? So it's going to do something here. Result. So when it goes ahead and loads that in, it's going to look at this and see, I guess content size is what gets used there, content size. And this is going to be entire file. So we're going to load that in. Oops, entire file. And then we're going to go ahead and do this stuff. Now, we've got these bit scans here, which I guess means we're going to need those intrinsics, which we could, I suppose, also just cold use. I don't think there's any reason not to, right? Does it? Or, yeah, so that's totally fine. We do have a v4 that we're using here, and we need our sRGB mapping stuff. So we are going to kind of need a little bit more. That's kind of making me think like it was maybe a mistake to say no math, because it looks like we're going to need the math, right? If that makes sense. So we're going to want these guys, sRGB 255 to linear 1 and linear 1 to sRGB 255, right? And those, I think, we had in here. I feel like what we're probably going to want to do there is just loft these up into the math so that they can be used by everyone, right? So that should be fine. So that's everything for that. And now I feel kind of stupid for not just including the math thing originally, right? Because now we could just have the things be v2s, but whatever, live and learn. It's probably not worth changing it back now. And so what I want to do is I want to go to the sounds and do the same thing, right? I want to have loaded sound be able to operate in here, and I want it to do whatever it is that it was going to do same way, right? So we have entire file, and we do read entire file, same thing. And now we are compiling. So now we can do the same loading that we were doing in the game, and know that we're loading stuff exactly the same and prepping it in exactly the same way that we had wanted it to be prepped, if that makes sense. So if we do that, what I can now do down here is I can just say, well, I guess I don't even need a switch. There's only two things. I can just say, okay, well, what type of asset actually is this thing that I'm processing right now? If it's a sound, we'll load it. Otherwise, we'll process it as a bitmap. I'll assert that it is a bitmap and that it's not some other magical type, right? But yeah, so in here, what I would do is, I guess I don't need these things to be debug anymore. It's just load wave and load bitmap. So I can go ahead and do my load wave there. Let me, or WAV as I like to call it. Drives Jeff nuts when I say that. So here we go. Here is our loaded sound. I'm going to load it in, right? And let's see. Excuse me. So I'm going to go load this WAV file in. So I need the file name, which I have, right? I need the first sample index, which I also have. And I need the section sample count, which I guess what exactly were we doing with that? If this was going to be 0, so this, what I actually need to do is use the dest one there, because that's where that actually exists, right? That's actually in the HHA, because it actually gets stored out, right? So we're talking about this value right here. But the first sample index is the one that's pulled, right? So this would load our WAV in, and then we could choose to do with it what we wanted. And the same could be true for our bitmap, right? If we do load bitmap, we would pass the source file name, and we would get back the bitmap, right? And that seemed, is not quite correct. There we go. Load bitmap, is it load BMP? What did I call that? It's load BMP. There we go. So load BMP. So now we'd be loading all of the assets in, right? But of course, the problem is if we had a lot of assets, this would get ugly quickly because they never actually free the memory that they would be using here, right? So what I want to do is something like this, right? What I want to do is something where I just go like, okay, you know, when I'm done with these guys, maybe I do something like this, right? So I can load it in, I can write it out, and then I can free it, right? Something very straightforward like that would be nice. So once we load this stuff in, then we have to actually go ahead and fill in any data that we were getting from the file itself. So from the WAV file, like for example, the sample count may not have been specified. Like sometimes we just specify 0 as the sample count, and we then would get it from the file. I don't know if you remember when we wrote that code, right? If you look at the original code when we were doing debug load wave /wav, when we were loading this, you can see that we did some stuff down here where we're like, oh, okay, you know, the sample count, right? When the section sample count, we would actually do stuff with the section sample count if it was non-zero, right? But in the cases where it was 0, we wouldn't change it. So the sample count that we end up using would be dependent on whether we'd specified one. And we might just use the sample count from the file if we had specified a section sample count of 0. So we want to preserve that behavior. That was important to how our loading code worked because that was what was, you know, kind of getting chunks of things out. So what we want to do is go back through the file format and make sure that we're writing out all of the stuff that we might need, right? So next ID to play would already be set, so we don't need to set that, but sample count would not necessarily be set. So what we want to do is grab that out, right? That's something we want to grab out. Yeah. Now, something that it strikes me as also not being here though is channel count, because technically we were supporting multiple channels. So I'd also like to put that in there, and that would be something that would come from the Handmade asset loader, right? It's this channel count value right here, right? So I also think I want to go ahead and copy that into the file that's going to be written. So once I've copied those two things into the array that we will eventually write out over here, right? I then want to be able to, you know, just go ahead and take all the sample data and block write that out, right? So that's the actual data that's going to get written to the file, right? I'm going to write out, you know, very specifically the entire wave, right? I'm going to say the samples 0, which is that first channel. I guess what I'm going to do here, this is actually what I'm going to do. I'm going to put this in a for-i loop so they can support as many channels as if we ever added more channels, right? I'm going to say we loaded the wave, we look at what the channel count is, and we write out each individual channel. And we know how big that's going to be. Oops. We know how big that's going to be because we know the sample count, right, times the size of an individual sample is going to give us that, right? So we know that that's how big that is. So we write out the 1 or 2 channels of sound data, and that's the entire data for this thing. Now we need to tell it where that is, right? We need to tell it where in the file we actually are. And as far as I know, I don't know if there's a portable way to do an FTL that's 64-bit. So the same caveat applies here. When we do an FTL, it's not necessarily going to be 64-bit compliant. So, you know, caveat to anyone who actually is going to write these, you would need to potentially worry about actually being able to get past the 4 GB boundary by using an FTL that was actually 64-bit. And you can see, like, you can see that they've got these sort of Visual Studio ones and whatever, and yeah, I don't even know which ones you know you would use. Like I said, I never use these. I always go through Windows or Linux directly. But yeah, so you can kind of see, like, there's these other options available for 64-bit style offsets and that sort of stuff. And your mileage may vary in terms of which one the platform that you're programming on actually has. But here's the, like, FTL one that returns a 64-bit integer, for example, right? So I'm just pointing that out, you know, giving you what the idea is there. So we have the fwrite, excuse me. But what we want to do is make sure that before we start doing these writes, we figure out where in the file we are, so that the destination's offset data, right? Oh, and I guess this is actually that. Right? The data offset that we store in the file needs to know that, you know, needs to point to where we actually start writing it. So what I want to do is use the FTL there. Again, I'm just going to use the regular one, right? Because we know that we're not writing out 4 GB for this test case. I'm going to go ahead and say, all right, the data offset, let's do the FTL to get the 32-bit value back, and we'll just treat that as good for now. So when we do the FTL of out, it'll tell us where we are. We will then write the stuff out, and then we will free the memory that we used to hold the contents temporarily while we wrote it, right? Exact same thing happens with the bitmap, right? If we look at what the bitmap actually has in it, it's just got the dimensions and the align percentage. This we know, this comes from the file. So we're going to do essentially the exact same thing. In here, we're going to say, like, dest bitmap.dim0 equals whatever the file said the dimension of the bitmap was. Same with this one. And I don't know. We have to think for a second about how we want to handle pitch. So let's just do this part first, and then we can talk a little bit more about that. So I don't remember what loaded bitmap had in it. Where's the renderer code there? Loaded bitmap had just width and height, and that's what we actually want. So we want width, we want height, like so. And then what we want to do is do the exact same thing we did here to write out the data, right? We just want to do an FTL to say this is where the data is actually going to be. And in some sense, I guess we could have just done that. We can just share that. That's going to be the same, right, between each piece of code. It's just wherever we are in the file at this point, that's where this thing is, right? So we don't have to do that in both branches. We only have to do the part that's specific to either branch, right? So that's fine. So if we do that, excuse me. In fact, we could even be a little bit more snarky here if we wanted to. I'm not going to be. So anyway, we go ahead here and we pull out that data for the dimension in there. And then what we want to do is we want to do the same thing we did for the sound, but instead of writing out, like, the samples, right, we have to write out the bitmap bits. So if I go ahead and do memory, what we need to know is how big this is, and we know that it's going to be, right, the width times the height times 4, right? Times 4 bytes per pixel. That's what we are always going to keep our bitmaps to be formatted as at the moment anyway, right? So the problem here is that if the size, we could actually just assert it, I suppose, that the stride and the width are equal, right? That the bitmap, right, the bitmap pitch is going to be equal to the width times 4, so that everything's nicely packed. And so what we would want to do is, if we have bitmaps that don't conform to this format, where there's no extra, there's no padding basically on the rows. If we have ones that had padding on the rows, we would want to write little code here to strip that out. Because we don't want the load time code of the game to have to deal with multiple pitches. We want them all to be fixed, I think. Or if we always wanted them padded to a particular thing, we would want to introduce the code here that does that particular padding, right? So that's that. So that is that. But now we have to go actually implement these guys to load actual pointers to freeable memory. So let's take a look here. We have the sample count. The loaded WAV apparently doesn't have the sample count in it. Why is that? What did I do wrong there? Oops, loaded sound. So it's okay. Oh, is it this one that we're actually complaining about? Let me double check at what the file format says it has in it. HHA sound. It's sound dot sample count. What is it complaining about? Cannot convert from loaded sound to loaded sound star. That's fine. We're going to fix that in a second. Is not a member of HHA asset. Oh, it's the one down here. Oops, my bad. Jump to a conclusion there. Let's see. Cannot convert argument 4 to file star. Oh, of course, I mixed up the order, as I often do with fwrite. There we go. So here we are. Load BMP. That's fine too. And this guy obviously is going to be the wrong order as well. So we'll just flip that around. Okay. So now, in memory, oops, we accidentally got a dash out there. So now we've got all of that stuff set up. We just need to actually make these guys return a chunk that can be freed, if that makes sense. And we need to implement this read entire file thing to actually, read an entire file, if that makes sense. And I'm trying to think of, I don't know if I actually, I don't really even need to do it that way. I'm just going to do this, right? Something like this. Let's see, void memory, or void star free. I'm just going to do it that way. That's a little bit easier than doing anything more complicated with it. So at that point, these can actually just look like this. Free wav dot free, free bitmap dot free. All right. So I think that's all good, and I just have to make sure that these pointers here change to dots. The curse of C, no one knows why they did that. It makes no sense, but that's just the way they did. What are you going to do? Let's see. These are also wrong. So are these. And so is that. Oops. So is that. Okay. So now what I have to do is actually implement this loaded WAV, this bit here, right? And so I have to do the load WAV and the load bitmap. I have to implement the read entire file function, right? Because it's not actually doing anything right now. And once it reads it, when it does the result thing here, I'm just going to say, oh, by the way, if you could just free that memory, from the contents. And the same is true for the load WAV, right? So read results, oops, result.free is just going to read results.contents. And so that just frees the memory. Not like we care, I mean, it's just an asset processor, but if you imagine a huge number of assets, you might blow out memory if you were never freeing it or something like this, so just seems like a reasonable thing to do. So anyway, in read entire file, what I want to do is malloc, the file size, right? I want to fread, which is the opposite of that fwrite, right? I want to fread the file size in as like one big chunk. and into like basically the result.contents, right? In fact, I guess you could say we want to do this, right? We want to do content size, so we want to read in the whole thing after allocating a chunk that fits it, right? So that's really the entirety of what we're talking about here. It's not out, I guess it's in at this point, right? So what this is going to look like is really very simple. We're just going to define a new file handle. We're going to say that the input file, right, is going to be read as a binary file off disk. Again, this is the same fopen we were using before. It doesn't really matter if you know these things. These are just the C runtime libraries, ways of loading files. Like I said, not going to be used in Handmade here at all. It's only in this asset processor. So assuming that we got it, we'll do that. Otherwise, we'll just print a little lame little error message here, printf, right? Error, cannot open file, whatever the file name is, right? And so then what we would do here is we just need to know how big this thing is. Once we know how big the file is, we can read the whole thing. We can allocate space for it, read the whole thing in, right, and then close it. And that's all we would need to do. So we just need to know how big the file actually is. And what we can do for that, right, is you've already seen this fseek. Remember when I said, well, fseek allows you to do seek end and specify a number of bytes from the end to seek. So what I can do is just seek to the end of the file, seek back to the beginning of the file, like this, right? So seek to the end, seek to the beginning. When I seek to the end, the ftel result, the file position that it would report to me, is going to be the size of the file, right? Because I've gone all the way to the end. So it's just a little hacky, but I don't know if there's a cleaner way to do it in the C runtime library. So yeah, that works in a pinch. Excuse me. So content size, I misspelled there. It's actually contents size. So that's basically it. And if I'm not mistaken, we've more or less finished the code we actually want. Let's take a look, though, at what it's doing, because I kind of just slammed that in there somewhat willy-nilly. So, you know, we ftel the data offset. That's where it thinks we're going to write to. We're going to load a WAV file in here. Oops. Looks like we did not load the file. Oh. Well, there is one thing that we will have to do, which I didn't think of. The first asset in all of our stuff is intentionally left blank, right? So in this file, we can't just assume that we can actually load the file name. The file name may intentionally have been null on that first value. So what I could do, I guess, is just start after the first index, because all the rest of the ones should be non-null, right? And that should be fine, I would think. Let's find out. So if I come in here and load a BMP, what happens? Oh dear, that doesn't look good at all. I wonder if this code is not. Let's step in here and see if I'm doing this correctly at all. Step in there. I want to open. What am I opening? Test Hero Shadow. So we're able to do that. Let's see how big it thinks it is. 125, 130. Let's see if that's commensurate with the actual data. Like, just, you know, because we're trying to make sure we did this right. Yeah, so that's looks correct. We seek back to the beginning. Oh no, typo. We did not seek back to the beginning. We seeked nowhere. Do you see that? It's supposed to be seek set. I want to set it back to 0 to the beginning. Seek set is relative to the beginning of the file. Well, that would do it. Let's try that one more time. So I want to come in here, do the read entire file. Is this now a little more? Yeah. So now we've got the values that look a little more correct. We come through here. We do our bit scans and all our other good stuff. Let's step out. See what we get here. What's our dest look like? Dest. So the data offset's there. Its first tag is 1. It didn't have any tags. because it's 1 pass last is also 1. We have the bitmap itself. Its dimensions are 144 by 217. Looks right. Its align percentage is 5 and 0.156682029. Well, maybe that's correct, but maybe it's not. Nope, that's fine. Well, what do you know? That's what we wanted. Okay. We're going to assert that it's aligned properly for our purposes, and then we're going to go ahead and free it, and then we're going to come back through. So that's going to write a bunch of bitmaps out, and so we can come back in here and do our load wave, see if the load wave also works, write those guys out, free it. So yeah, off we go. There's their asset processor, quote unquote. And you can see that we now have a 17 megabyte file that is our bundled asset file. Now, I don't know if that's actually the size that it should be, because we haven't really done any validation of anything yet. But I suspect that that is probably correct, maybe, because half of this guy, right? We're one channel of the music test, which I think is all we keep now, right? I think we're only doing one channel, right? Is going to be like 15 megabytes. And then all of these guys are very tiny, so they could easily only add up to 2 megabytes. That seems plausible. So we don't know that our code is working at all yet. It would be very premature to suggest any such thing. But what we do know is that we are not totally implausible. And so if that worked properly, what we have done is replaced all of these test files in here with one file that's just test.hha, which includes all of the data for the game, right? So now that we've done that, the next question is, could we use that for our actual game and have it run at all? We've only got 10 minutes, so that might be a little bit too much to bite off at the moment, but we can certainly start, and we're going to need to start validating the file anyway, so we might as well go ahead and do that. Now, if we take a look at what's happening in here, where I set this structure up, what I can do, I'll verify that we're running the way that we thought. Oops, that's the asset builder. Don't need to run that again. Let's go back to Win32 handmade.sln and run it. So we're running that. We should probably also, just for good measure, because it's a little odd, we should probably take out that piece of test code that's in the audio mixer that forces all sounds to play really fast, right? Like, that is, I don't believe that that is what we wanted. So 1.9, we'll get rid of that 1.9. So now we're playing properly, right? And you can see all the assets in the game are working properly and all that sort of stuff. So what we want to do now is see if we can just switch over to using that pack file, right? So let's start. So the first thing that we're going to do this is figure out what the stuff is that we actually wanted to initialize correctly, right? That is actually being initialized here, and what stuff we just don't care about, right? So the debug stuff can all go away for the most part, right? Like the debug stuff here can all get removed, like so. And so we would really only have these left over, right? We would then get rid of like almost all of this stuff, right? Almost all of this would go away. So we'd if0 this out. Yeah, it looks like all of that is all going to go away, right? So all that would go away as well, as would pretty much all of this stuff, right? Would go away as well, right? So all of that stuff would go away. And what we would have to do now is we would have to sort of, we're going to have to kind of do this into two tranches because first I want to use our existing debug file load routine to load the whole file into memory and just use it that way. And then after that, we will go and add a path to our Windows platform layer that will actually do proper overlapped I/O for us. So let's go ahead and if zero out the rest of this. Like so. And so really what we've got is now these sort of load, these guys here, right, is what's actually happening. So what I'd like to do, there's a pretty good way, I think, that we could stub these out. I think there's a pretty good way that I should just say, first of all, when you're doing a big code change like this, you've seen me do it many times. I don't know if I've ever explicitly said it. I like to schedule the workout in my brain in tranches, right? I like to be able to go, let's make one change and validate that it's working, make another change and validate it. I don't just try to do the whole thing at once unless I've figured in my head that really that would be very efficient to do. I like to kind of do it in steps so that I'm not taking too big of a leap of faith, so I can see how it's working out and potentially save myself some trouble if I go, no, not quite. So, and similarly with debugging, if I replace only one thing at a time, it's easier to debug because I know where the bug might be. Whereas if I replace everything, I have no idea where the bug is, right? It could be in any of it, and it's harder, it takes longer to kind of isolate it down. So that's, just to be a little bit more explicit, sort of philosophically and conceptually about what's going on there. That's sort of where I'm at. So what I'm going to do is I'm going to take the debug load bitmap, the two debug ones, right? The load wave, debug load wave. I'm going to stub those out like this and just do like assert no, right? And then I'm going to do results equals some other thing and return, right? And similarly for debug load BMP, I'm going to do, what happened? I am going to do debug load wav. I'm going to do the exact same thing for it. Assert, not assets. No. Loaded bitmap, result equals blah, return result, right? So now we compile. Of course, I have to actually put these in the correct order. So let me shift those up to here. So now, we just wouldn't run, because immediately when an asset was needed, it would assert. And it would just say, no, you don't have that, that asset. Although, for some, or it wouldn't. That's a bit odd. Oh, right, because it doesn't think it has any assets. That's a kind of cool, it's kind of cool how that works, right? When your whole asset system is based on queries like this, you can just remove all the assets and the game doesn't like crash or anything. It tries to build bitmaps and it says, oh, there weren't any, and it just keeps on going about its day. That's kind of cool. All right, well, anyway. So now what I'd like to do is try to restore those assets by using debug read entire file to read in the entire, that entire HHA that we wrote out, right? So what I want to do here is I want to say, okay, read this whole thing in, and we're going to read in that, what was the name of that guy? Test.hha, I guess, whatever it was, right? We're going to read that whole test.hha thing in. We're going to then go through all the assets in it, and basically we're just going to like kind of plug our stuff to sort of reference into the file memory. So we loaded the whole file into memory, and I'm just going to flat out romp straight over the other stuff in here with pointers directly into that file, right? So I'm going to say that we overwrite all of these guys, the asset count, right, the assets themselves, all of that stuff is going to get overwritten by the stuff that's in there, right? Okay. So the tag array is pretty darn. I guess I kind of do have to, now that I think about it, do it a little bit more. I want to actually do the change over processing. So I take it back. I'm not going to quite do it directly that way, perhaps. So what I will actually do this, right? I'll actually do the asset count equals like, you know, whatever the HHA headers asset count was, right? Because we'll know what that is now. And then I'll push the right number on there, and the same will be true for the tag count, right? Like so. And so then we'll have the arrays, and then I'll just loop over them all and actually set them up, right? And we've got 3 things to loop over: the tag array, the asset type array, and then the asset array itself. So here's the tags. And right now we're not actually doing the tags, so we may just flat load the tags. The tags could just be pointed to directly. In fact, we could, yeah, I don't know how we'll want to do this. I'm going to loop through them for now, but we could just turn them into flat loading. And I'm going to say, this is a to-do for next time, right? Decide what will be flat loaded and what won't be, right? But for now, I'm just going to actually interpret all the data, which is just, it's not going to be, there's no reason for us to do that, so we'll eliminate some of this in the next pass, I think. So, you know, what we would do here is say that we have, again, a source and a dest, essentially. We have an HHA tag, which is the source this time, because that's where we're pulling from in the file. So we would have basically the HHA tags, that one. And then, I'll keep these off for now. And then we have our asset tag. That's the thing we actually use, and that's the dest. And that's going to be the assets tags array. And for each of those, we're literally just going to copy the 2 values that were in there, right? It's just ID and value. So it's like dest ID equals source ID, dest value equals source value, right? So really all we need to do here is now actually get at that data. Now what we know is what we loaded is an HHA header, right? We know if we look at the file format, that's what we wrote out as the first thing in the file. So if we literally just straight up cast the read result contents, like the file data, if we straight up cast, I don't know why I called it HHA header, and it could just be header. It's not like there's another header. The HHA header is just the first, starts at the first byte of the file, right? And we can assert that the header that we wrote out has the magic value that we expect. So we know that we actually, you know, are reading one of our files at the moment. You know, so while we're debugging it here, we know that we're not crazy. And we can do this HHA version as well to double check those. And then from there, we can just use the asset count and the tag count and so on. But then we also need to figure out like where like the HHA tags are and stuff like that, right? So we have HHA tag like that. That's just going to be, again, casting to an HHA tag the read result contents. But this time, we need to move forward a bit, right? We're going to start at where the content started, but we're going to move to the location of the file that we wrote out to tell ourselves where it would be, right? So we know that this is where the tags are, right? So we're just going to go ahead and say, all right, you know, wherever the header says the tags are, that's where the tags are, right? So it looks like I didn't include this stuff in handmade.h, so I'm going to now. We did not include the file formats in our list of stuff, so I'm going to go ahead and do include handmade file formats.h, like so. I'm going to go ahead and put that in there. And then, oh, right, and I forgot to add this guy. I meant to add this guy. Like I said, I've been playing around with what I like those types to be named. And I've been debating on whether I like the 0.8 or the regular 8. And some people online were saying it shouldn't use the 0.8, and I tend to agree with them. I don't know. I like it to line up, but then sometimes I don't. It's just, you know how it is. So anyway, let's take a look and see how that actually goes. But we're a little bit over time, but you know, that's how it goes sometimes. So let's go through here. If we load this thing out, let's see first of all, if we step in here. Here's the header. The magic value is what we expect it to be. The version is 2. The tag count looks right. Right, we got the 17 different asset types. We have 51 assets in there. We've got 44 tags, right? And our HHA tags array, right? just look at a few of them. Looks exactly right, right? So we've loaded the data in, it looks like we've loaded in the data properly for the most part, right? So I would say that's pretty good. So I think we stop there for now. And what we will do tomorrow is we'll just finish lining and stuff up in the file, like pulling that stuff out of the file and verify that everything works properly. And then from there we can just move on to loading it out piecemeal, right? So yeah, so that's all good. Let's go ahead and go to the Q&A for people who have questions on what we did today. Hopefully that was all pretty clear. We basically just wrote that stuff out to the file, and now we're just loading in the stuff from the file and picking out the pieces of it that we know are the data that we actually want, if that makes sense. All right. So go ahead, and if you have questions on what we were doing, go ahead and please preface them with Q:, so I can see them, and I will go ahead and answer them. And I see people talking about how long it's been going for. Yes, it has been going for 149 days, but we only code 1 hour a day. So it's basically like 149 hours. But once in a while, we've done a long stream. So it's, it's probably more like figure 160 hours or something like that. So if you divide that by 40-hour work week, you're talking 4 weeks. Gasto5 asks, what does flat loaded mean? I guess I don't know why that term is what it is, but I can tell you what I mean by it and what I tend to hear people mean by it, right? So flat loaded can typically mean one of two things. The first thing is, here is the file, right? Here is some data, and here is the memory in use in the game, the actual memory that's going to be used by the game. Flat loaded means you literally just load the thing straight away as a block into memory, and the game just runs straight off it. I believe it's flat loaded because you're not relocating it or you're not allocating pieces, right? So by comparison, a parsed way or a piecemeal, right, way of loading a file is sort of what I kind of implemented there, where it's like, okay, whether or not I load the thing in as a chunk is not really that relevant to this part of the discussion, but it's whether I run out of it directly, right? So if I load this thing in and then I start looking at it and go, oh, here's a thing that says there were 5 tags, so I allocate some tags here, and then here's one of the tags, so I put that in here, right? That is that's not this, right? That's the other way of doing it. And it's kind of the more, it's clunky and cumbersome, and you don't want to do this, right? You're wasting a bunch of time in your load if you can figure out a way to not do it, right? So typically that is what flat loading means. Usually, and probably even in Handmade Hero, we'll want to be doing basically that, but there's usually another step. So usually what happens is we decompress, right? So we want to do something where, yeah, we load in a block, we decompress it, and then we slam it into the data and use it directly is basically what we're going to want, which is pretty close to flat loaded, but not exactly, because there is this step of blowing out the data, right? Someone during the stream asked about the benefit of keeping all assets in one file as opposed to making different asset files dedicated to each type of asset. I want to make sure that I actually understand the question that you're asking, because I'm not sure if I do. Are you asking why have one big file as opposed to one file per asset, like one file per bitmap or something? Or are you asking why have one file instead of 2 files, one for sounds and all the sounds are in it, and one for bitmaps and all the bitmaps are in it? Because those are 2 different questions, and I want to make sure I'm answering the proper thing, if that makes sense. TTBJM, should there be error asserts if there are no assets that match a query? I don't know. Maybe? Maybe not? I don't think so. Probably not an assert. What we might want to do is have a way that it gets logged or something eventually. I'd say take a wait and see approach and see if we actually ever run into cases where we need that. Will you ever make games to make profit off? Yes, that's what I do normally in my day job. Let's see. The latter about the assets. Okay, so I'm going to try and answer this question then. So the person who was asking that question was asking the question, right now, this is what we have our file look like, basically, right? Right? This is what it looks like. And if we wanted to be more explicit, right, it kind of looks, you know, in more detail like this. There's the header portion here, right, is actually broken up into like a preamble, right, that really doesn't have anything in it, magic value, that sort of stuff, and some counts, right? And then some addresses of things. And then it's got some arrays, right? It's got tags, you know, asset types, and assets or something like this. I don't remember the order. It could be the other way around. And these things point, this array points into here, right? And it says where the various, each element of this array points into where the various things are. And we've got, you know, right now they would pretty much be in order because we define them in order. So it'd be like bitmaps would be coming first, and then eventually it switches to sounds, right? But we could interleave them. There's no, they just happen to be written out in the order in which the assets are defined, and we happen to define all our bitmaps first and all our sounds second, but we could define them interleaved and it would still work. So this is not really part, the fact that they happen to be bulked up this way is not really part of the file format. So what the person was asking was, well, why not do it so that you have this, essentially a file, one file that is this, right? And then another file that is this part with another one of these on top, right? So basically have, you know, two files where we have header data, and then one is just bitmaps, and one is just sounds, right? And these are the two files. So it'd be like the BMP resource and the WAV resource, or whatever. And not to answer a question with a question or anything, but my first thing that comes to mind as to why not to do this would be, why would you do this, right? Like, what's the reason why you would want to have more files on the drive than necessary, right? Like, it's just one more thing to worry about, right? If I only have one file and that file has all the data in it, then I know that when I opened that file, that's the only error I had to check. It's like I go, okay, can I open my resource file? Yes, then I know I can get all my resources. And the only thing I ever have to worry about is if one time I go read from this file handle and the OS says it's gone or something, I have to go, hey, Mr. User, just so you know, your machine is broken, basically, right? Or something like this. If I have two, then that just doubles the amount of work I have to do when I start up, right? I've got to now, I have to have one path for parsing the bitmaps and one path for parsing the waves. It just adds more stuff that can go wrong and more code, right? So the main reason is just, why bother, right? Like, why not just collapse it down into something simpler when there, what would be the actual benefit? And since I can't think of a benefit to having them separate, that is why I say, let's keep them in one, right? So it doesn't look like we have many on-topic questions. So I guess I'll take a couple off-topic ones before winding down. Where did I learn to code? I learned to code when I was little. My dad taught me to program when I was 7, and since then I, am self-taught. How long have you been coding? For 30 years. Is this what you do full-time? Do you work for a company? Yes. I run my own game research company here in Seattle. And that is what I do full-time, not this. This is a sort of pseudo spare time to some degree activity, but I make 2 hours for it every day to make sure that we do it, and it's basically I'm trying to kind of do a programming education project, if that makes sense. Will the game be multiplayer or single player, and will you be able to code your character kind of like code spells like the name Handmade here would suggest? No, it is not like code spells, and it is single player. Although the game as it ships will be single player unless we see some way to make the design not be a problem that way. But so the game as it ships will be single player, but we support multiplayer for the purposes of me showing how to program it, right? So even right now in the game, when you hit the spacebar, you add your hero and you can walk around or whatever. Even right now in the engine test code, if you were to plug in a Xbox controller and push a button on it, it would add a second hero. So we're pretty much making sure the code always allows multiplayer, but the design is not supposed to be multiplayer. So the game will not really be multiplayer, but the code is throughout the entire development process. We will leave the code in a state that allows multiple people to play at the same time, even though I don't think we want to ship it that way because it won't be a fun. It's not designed to be a fun multiplayer game. It's designed to be a fun single player game. So there's that. Off topic, why is your bio web page not viewable without JavaScript? That's because my web page, I hate the web, just pretty much period, and everything about it. I hate HTML and CSS and JavaScript. I think they're all awful. So I've done some experiments, and my web page was one of them, with ways of making websites that don't involve them in the source. So the way my web page works is actually that it's a C program that does layout, and then it just spits out JavaScript as like a back end, like a compiler sort of thing, that produces the layout that I made in C. It was a spare time thing I did. It's not particularly good, but it's just kind of what I was interested in trying. And I learned some things from it. And actually, I went back and forth with a dude from Firefox, figuring out how to make it really fast. Because there's actually a bunch of things that won't work because JavaScript is so slow. And JavaScript and HTML are so incredibly slow that even doing really basic layout is almost impossible if you don't know some very specific tricks, if that makes sense. What is a bitmap? A bitmap is just it's really a misnomer. So in the earlier days, it was a little bit more accurate. So the phrase bitmap used to sort of mean, if you imagine in binary, right, you've got ones and zeros, right? That's what a computer thinks in terms of, right? And so in the old days, a bitmap was literally a real thing. It really was a map of bits. It was like, oh, I want to draw something, right? So I've got these zeros and ones, right, that actually represent where the data, what you should color in, and what you should not color in. So if I wanted to make an H, right? This is how I might store the graphics for an H in a quote-unquote bitmap in the real sense of the term. Right? So you can see that it makes an H with the ones and the zeros are where the H is not, right? And that would be a traditional bitmap. It is bits that form a map, a two-dimensional image, right? But over time, obviously, displays, when displays were monochrome, a 0 and a 1 would tell you all you need to know. If it's just black and white, that's all you would need to know to make an image. But over time, as we've added color, it's not sufficient. So what we've done instead is replace this concept with sort of what you might call more appropriately like a byte map or a multi-byte map. Because what we actually store at each location in the H is a full RGBA color set where there's 8 bits used to represent each of these. So you can have between 0 and 255 levels of alpha, blue, green, and red, right? So the term bitmap is now used to mean, I mean, it's still all stored as bits, right? I mean, everything in a computer is in terms of bits, so it's not a complete misnomer or anything. But where the term originally arose, I think, probably if you dug back into history, they were probably talking about actual bits per pixel. Like every pixel on the screen was 1 bit on or off. That was probably what a bitmap more traditionally meant. Now that's not true anymore because we've got color, and it can even be fuller color than this. It could be 16 bits per gun and all and so on. So, have you been doing this all your life? Yes. What is the Windows 10 release date? I don't know. Sometime this month, I think, right? What is your day job and do you enjoy it? My day job is making games, and yes, I do enjoy it. How many years of experience do you have? I already answered that one. Okay, let's see what we got here. What is overlapped I/O? Overlapped I/O is just the name of the system in Windows that allows you to issue asynchronous reads to the hard drive. I will be covering it in great detail in the next couple of days as I show how to use it to do asset loading. Siastek3214. In that case, why do other developers break up their assets in separate files? Again, I'll ask the same question. Do you mean why do developers break up their assets into one file for sound and one file for bitmap, or into individual files, one for each asset? And if it's the former, I actually don't know any developers who break up their assets into all the bitmaps go one place and all the sounds go into another. I don't actually know of people who do that. That doesn't mean they don't. I just personally don't know. So I couldn't say why they do because I've never actually seen anyone do that. If you're asking why a lot of developers just leave it as a bunch of files on the drive where there's one file per asset, I don't know. I probably because they just never have written pack files before and don't know how or don't want to be bothered with them. I don't know. Would having separate files assist with modding or patching? Not really, because the way we've spec'd our asset files is you can have as many of them as you want still, so you can always add more. So I would say that actually it probably doesn't matter. Patching maybe, because patching, we'd have to think a little bit about how we might want to do patching if we wanted to do patching in a way that knocks out existing assets, right? Although I think we will actually just get that for free. But so yeah, I don't even know that, to be honest. I think all that may just work. Is Mike Acton's data-oriented design any different than compression-oriented programming? Yeah, so Mike Acton's data-oriented design stuff is sort of talking about they're sort of different parts of the procedure, really. Compression-oriented programming is kind of how you do architecture, right? It's about taking code that you've written and sort of pulling it out into things that are reusable or that have more leverage or whatever, right? What Mike Acton's usually talking about with the data-oriented design is talking about the first step. Like compression-oriented programming is kind of like the second step. He's talking about like the first step. He's saying the first thing that you should do when you write the actual code is you write the thing that actually transforms the data in the way that it's supposed to work, right? You have data and you're trying to move it from one place to another and change it. Like that's just what code does, right? Or leave it in place and change it. But that's all CPUs could do, period. So we know that that's the entirety of the problem that you're solving, is a way of mutating data either in place or en route to someplace. So he's saying orient the code around that, and that is totally correct. And that's basically what we do on Handmade here all the time, right? That is exactly how you want to do that. But data-oriented design doesn't really speak to what happens when you want to try to start leveraging some kind of higher level structure. And that's what compression-oriented programming is. It's about saying, taking things you see that are similar, pulling them out, and making sure that they still stay true to the data-oriented design that you had. So you don't want to modify what it's doing. You want to let it do, you want to make sure the thing that it does is the same. But you're trying to get it into a place where you can reuse it in more than one way. One reason to split files is to get around the FAT32 4 GB limit. Another reason might be if your pipeline allows audio devs to update their pack file for the game without needing or messing with other parts of the game. Well, that's a separate thing though, because that's during dev, right? There's a difference between during dev and how you ship the game. So yeah, that's sort of a separate thing, I would say, in some sense. The FAT32 part, I don't know, like, is there really a lot of FAT32 going on still? Like, do you really have... I guess if you're trying to transfer things on a thumb drive, maybe you would see the old 4 GB FAT32? I don't know. It's hard to say. Where can we read about the actual plan for the game? That is not released yet. Are you using any C++ plugins for Emacs? No, it's just the standard vanilla, the standard C++ mode that ships with Emacs by default. Won't the game have to wait until all the assets have been decompressed before the game can start? No. So the way that we would do that, right, is in here where we have these bitmaps, right, we would just compress each one individually. So when we go to fetch a particular bitmap, we only decompress like the bitmap that we want. We wouldn't like compress this whole block as a single block, and so that we'd have to like decompress all the bitmaps to access one of them. So we would set up the compression that we would do to allow that random access, right? Why are you using Windows instead of Linux? That is answered on the page you are looking at right now, in fact. That's answered on the Twitch page, but the answer is just that because nobody buys any games on Linux. You know, you can sort of see this answer for yourself, actually. If you go to the Steam hardware survey. So, you know, you're a game developer. You have to make money to stay in business. That's just the rules of the game, so you have to sell some copies of your game. And so if you take a look and you go to the OS version, right, and you take a look at where you're going to sell those games, on Steam, 95.77% of the people you can sell your game to are running Windows, 3.22% of them are running OS X, and Linux is essentially nobody. So while it's, you know, it's nice to support OS X and Linux for a couple reasons, which I'll talk about in a second. If you are a game programmer, Windows must be your primary platform of knowledge, because the vast majority of people who will play your game as an indie game developer, if it's on PC, is Windows. Nobody will be playing on OS X, and nobody will be playing on Linux in terms of the numbers that actually, the actual fan base that you will be reaching. So, that is why Handmade Hero is on Windows first. It's because that is the platform you must know, and is the platform you must get right. If you do not get Windows right, your game will be a massive disaster when you release it, because everyone will complain on your forums that it's not working on their machine and blah, 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 right? And you'll just have a disaster in your hands, because 95%, basically every single person who bought your game was running it on Windows, right? You know, out of every 100 people that bought your game, only 4 of them were running it on something other than Windows. 96 of them ran it on Windows, right? So at that point you may ask, well, why bother porting to OS X and Linux at all, right? Because, and on Handmade Hero, once we finish the Windows version, I will be showing how to port it to OS X and Linux. And there's 2 separate reasons for that. One reason for that is simply to make sure writing portable code is a good skill to have, and it's good to learn. because you don't know that Windows will be the 96% case forever, and you also don't know if you might want to run on a console. Maybe you want to ship on PS4. Maybe you got to deal with Sony to ship your game on PS4. You need to have the experience of how to write code properly to ship on more than one platform, because in game development you will often be expected to ship on at least two platforms that have to work well. And so that's, one reason. So porting a game to multiple platforms is just a good experience, and I want to show how to do it. So there's that, and it will be something you'll actually have to do. It may not be OS X or Linux that you will be pressed into shipping because of actual market concerns, but it might be like Windows and PS4, let's say, right? So there's that. But the other reason is just that, let's be honest, Microsoft is really antagonistic to game developers, right? They are absolutely awful to us. They basically do everything they can to make our lives miserable. And this is like across the board, right? They won't backport their graphics library. So if you want to target D3D12, you can't run on Windows 8 or Windows 7. You have to target Windows 10, which means if you're going to target multiple things, if you use D3D12, you have to write a D3D11 backend to run on the older platform, right? So, and they don't care, because what they want to do is they want to make sure people buy new Windows versions of Windows, right? And they don't want to do the extra engineering work or whatever to support the multiple platforms or who knows what, right? So they don't have your best interests in mind. They have their best interests in mind. They want to promote the Windows Store, so they don't allow you to write in the desktop stuff anymore. You've got to go write in the Windows RT layer if you want to do stuff like show a lock screen notification, right? Because they have an agenda. They want to push their Windows Store. They want to take 20% of your money, or I guess 30% of your money now, or whatever it is. They have all these agendas, right? They don't care about you at all unless you have some kind of monetary thing or clout, or maybe you'll complain too loud, or like, they don't care about you, right? They care about them and making money, and they have never historically been nice to game developers, all the way back to, like, say, when they introduced Games for Windows Live and wanted to charge players an online subscription fee, and like tried to get people to go through this like archaic, weird, bad service that was lousy, and then they discontinued it so all the games that were on it stopped. Like, their pattern of behavior is extraordinarily antagonistic to game developers, and especially to indie game developers, because indie game developers don't have any muscle, right? If you're, let's say you're the people who make Call of Duty, right? You're Activision. You have a lot of muscle, and you could throw some weight around and get what you want, probably, right? We don't have that as indie game developers. There's nothing I'm going to ever say to Microsoft that's ever going to make them do anything for me or help out fixing some, thing like that that's antagonistic to Handmade Hero. That's just not going to happen because it doesn't have any clout, right? And so, in my mind, they are a very dangerous thing that we are reliant on in a very heavy way. That's this number right here, right? They are very dangerous and very troubling to me. It bothers me a lot that the 96% ownership of games on Windows is a company that is openly hostile to us in many ways and has often proven that they are totally happy taking that stance. So why port a game to Linux at all? Because I'll be honest, at some point we have to figure out a way to solve this situation. And keeping all of our games portable and shipping games on Linux, even though you know you will not even make back the money it cost you to port it, is still something that maybe makes sense to do, because who knows what could happen. Maybe Steam Linux starts succeeding. And the only way Steam Linux is going to start succeeding is if there are games there to be played on it. We can help make that be true by shipping games on Linux. Once that starts succeeding, now you have two competitors in that sort of PC gaming landscape, Steam Linux and Windows. And as Steam Linux starts gaining traction and this number goes up, now Microsoft can't be so antagonistic because there's this other place we can go, right? And so, if there's one thing we've learned from history, is that Microsoft is openly antagonistic to game developers at every possible opportunity, and there is no way that just counting on them to do the right thing for us will happen. But if we have alternatives and we have competitors that are essentially going to force them to do the right thing and force them to be nicer, they will, right? Because they have to. Or they just go away and we don't care there either, right? Because Linux is open and always will be, so we don't have to worry about that part, right? So in some sense, the reason that I would say, even though Handmade Hero is on Windows first, and if you are a game developer, you kind of have to be Windows first at this point, it's true. It doesn't mean don't ship on Linux, because there are very important, very real reasons why you might why it's important for our industry to have some backup there, right? Actually, if you look to on Handmade Hero, I gave a lecture recently that's about this. If you're concerned about that kind of stuff and the fact that there's a lot of indications that that the platforms that indies rely on are kind of in a little bit of overhanging jeopardy, the Terminator gene, which is a lecture I did, it's on the Handmade Hero video stream. You can watch it. It's 30 minutes. It's kind of entertaining. It's something that kind of talks about the real risks involved and the ways that we as an industry need to kind of think about starting to sort of shore up our platform so that we aren't so beholden to an openly hostile single platform, right? So we're about over time, so I'll kind of end it now. Can you say something on stream to get Reddit angry? They're already complaining about your oops statement. I kind of feel like Reddit is always angry, so I feel like we don't really need to say anything to make them angry. They just will be angry. So. All right, looks like that's it. Implete says, but you can code on Linux for Windows very easy, right? Not really, no. I mean, you can run through Wine, right? And do your development emulated there, but that's not a very reliable way to test, right? Because you need to test actual Windows, because Wine is completely different from actual Windows. And so you don't really want to be testing your primary platform through emulation. That's not a good way to go. You want to test your primary platform with the actual platform. So yeah, I wouldn't recommend that. You could try it, and maybe then just when you go to do your testing, test on actual Windows in a number of SKUs, which you're going to have to do anyway. So you could do it that way. It's not how I would choose to do it. And I also don't like developing on Linux because their debuggers are really bad by comparison. To Visual Studio, which I know is scary because it's not like Visual Studio is amazing at debugging or anything, but the Linux debuggers are pretty bad. And that's been treaded. We've talked about that in the forums many times, and so I've kind of pointed out the reasons for that if you want to know what they are. But that's why I tend to stay away from using Linux as my primary dev platform at the moment. So, all right, I think we are about done for the day. Let me go ahead and close these up. All right. Thank you, everyone, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. If you wanted to follow along at home, you can always pre-order the game on handmadehero.org, and it comes with the source code. So if you want to play around with the sort of stuff we're doing, you can download the source code every night and sort of tinker with it, experiment with it, and it's a good way to learn if you're trying to follow the series as an educational thing. That's pretty handy. If you want to ask questions or take a look at past episodes on an annotated episode guide that the community members have done, or look at ports to Mac or Linux that community members have done in advance of us doing them, we have a forum site you can go to for that. We also have a Patreon page you can subscribe to if you just want to support the video series, and we have a tweet bot you can subscribe to if you want to know when the stream will be live. It shows you when it's going to be live for the week and then gives you little reminders every day when the stream will be that day. So if you want to try and catch it, you've got plenty of notice. That's about it. Tomorrow we will, I guess, check to see if our asset writing worked. We know that it sort of did because we loaded a little bit of it. So tomorrow we'll just load the rest of it in and we'll see how it goes. And from there, hopefully that will be relatively easy to verify that that's working. And so from there, we'll just switch from doing that single block load to actually just reading piecemeal out of the asset file. And then that's it for our asset file stuff. From there, we are just left with the memory management part of our asset scheme. And we will be pretty much done with our entire asset pipeline start to finish, which is great. So that's pretty cool. That'll be a pretty big to-do item checked off our list. and one step closer to having our engine pretty much ready to go. So thank you everyone for joining me. I will see you tomorrow for that. Same time, same place, 5 p.m. Pacific Daylight Time here on Twitch. So I hope to see you all then. Until then, have fun coding, and I'll see you on the internet.